Hi everyone, I'm Simon. In this lesson, we will add a new Java application to our team server so we can detect any vulnerabilities it may contain. The steps to add a new Java application are very simple. We download a contrast.jar file, configure it into the application server's startup script, then restart the app server to apply the changes. Let's get started. Here's a typical Java EE application called Ticketbook. Like your code, it's probably full of vulnerabilities. Just kidding. But really, how would you know? As you can see, it allows you to register, buy tickets, etc. So if we just pop some information in here, you could test it all day and still not know whether it's got any security problems. So now let's try it with Contrast. The first step is to go to your Contrast team server. I'm using the on-premise version of Team Server, but you may need to log into your company's SaaS account. First thing we're going to do is download our Contrast agent. Simply click the Add Application button, then choose Java. Contrast also supports .NET and Node.js. For Java, the agent is just a 5 to 6 megabyte jar file, and it has to be named contrast.jar. When we click Next, there are instructions here for all different types of app servers, but it's really easy. We just add the Contrast agent to our local server. There are many ways to add the agent into the app server. For example, through the app server admin console, editing the executable file which starts the app server, or configuring it through an environment variable such as Java opts. It just needs to include the contrast.jar file when the Java process for the app server starts to run. So for a Tomcat server, we'll simply follow the steps provided in Team Server. So first off, we'll head into our Tomcat installation directory, which as you can see, that's where I am. We'll then create a new file called startup-contrast.sh. Now, as you can see, I actually created this file a little earlier, but all we're doing in here is passing the Java agent option into the Java opts variable. And we need to make sure that the path to the contrast.jar file is to where that file exists on your system. In my case, that's just in my downloads directory. Once that's done, we're simply calling the normal Tomcat startup script. So we can go ahead and save this file. We can then shut down our current Tomcat process and start it up again using our new Contrast startup script. So that started up very quickly, but you may notice a few seconds delay starting up your application. That's because this is when Contrast is instrumenting your code with the security sensors it uses to detect vulnerabilities. Contrast actually also auto-updates to the latest version if needed, on startup or shutdown. It doesn't matter what app server, framework, libraries you're using, or how big your application is. Actually, Contrast is a lot like New Relic or AppDynamics, except that it's for security rather than performance. So at this point, Ticketbook is running again, and if we head over to Team Server, we can see that Contrast has already detected our application. So since it's a new app, I'm going to apply a license. And then Contrast has created a full security dashboard for Ticketbook for everyone on the team to share. So from this point forward, this dashboard will continuously indicate exactly how good or bad Ticketbook's security is. As you can see, Contrast has already identified a few vulnerabilities during startup. But let's find something serious. All we have to do is use Ticketbook normally. So Let me register again. Contrast is passive, so the application will work normally, but every bit of testing we do is also now doing security testing. And see, I'm getting Slack notifications from Contrast for every vulnerability. Let's take a look. So here's a critical one. Let's go and look at what we've found. So Contrast saw a SQL injection vulnerability. Here's the exact parameters I typed in, and Contrast traces the data flow through the application to line 217 in database.java. Here's the actual SQL query that went to the database without any escaping or parameterization. That's a classic SQL injection vulnerability, and it's pretty serious. Remember, we didn't have to hack Ticketbook, just normal testing. Anyone can do it. So Contrast has all the details you need to fully understand the problem and to make the fix. Here's what you need to do to actually go away and fix this vulnerability. Here's the full HTTP request, and here's all the steps in the data flow. You can even see the full stack trace by clicking on any of these steps. So this is the point that you'd actually go away and make the fix. If you're the developer looking at the vulnerability, you know exactly where to add the fix through the stack traces listed right here. You also have the full HTTP request, which contains the malicious data. This also gives you a test case to verify that your fix works. With this replay request button, you can in fact trigger the same request against your application a second time. If you're an admin, you can just send the development team both the stack trace and the HTTP request. We also integrate with common bug tracking tools such as Bugzilla, so you can easily open a bug right from Team Server for any vulnerabilities that you think need to be fixed. Once you've made the fix, you can go back to the vulnerability and mark it as remediated. This will remove it from the vulnerability view and only bring it back again if it's discovered in the application once more. Contrast covers more kinds of vulnerabilities than other tools. Here you can see a web.xml security constraint, cross-site scripting, clickjacking, cross-site request forgery, and many, many more. Oh, and Contrast also analyzes all of the open source components you use. For example, in Ticketbook, there's an old version of Spring with a vulnerability that should probably be updated. If we dive in here, we can see all of the details around this vuln.